So ever since we've been introduced to stoichiometry, every time we find another way to calculate moles, we do stoichiometry with that thing. So, we started out doing stoichiometry with masses, then we did solutions and we found that moles were related to the concentration of a solution. So we did stoichiometry with solutions. Of course, in the ideal gas law, um, we have moles in the ideal gas law, and so we can do stoichiometry with gases. And the next chapter, um, we're going to talk about the heat produced by a reaction, and the heat produced by a reaction depends on the number of moles of things that are reacting. And so we're going to do stoichiometry again with heats of reaction. Right? But fundamentally, it all comes down to the same thing. And so the moles of any one substance in our chemical equation is related to the moles of any other substance in our chemical equation by the balanced stoichiometric factors from the balanced chemical equation. And so then the trick is to just whatever they tell us about the substance, we have to get that into moles. Whether it's the mass, we'll use the molar mass. If it's a solution, we're going to use the molarity equation. If there's the number of molecules, we can use Avogadro's number. And now, if they tell us some information about a gas, its volume or pressure or temperature, then I can use the ideal gas law to get the moles. And the same, on the other end. Right, so it's not really any different than the stoichiometry we've done before. It's just instead of calculating moles with molar mass or molarity, we're going to potentially do it with the ideal gas law. So I have one example here, and then I have a separate video with a second example. So we want to know what volume of H2 at 738 millimeters of mercury and 355 Kelvin is needed to make 35.7 grams of CH3OH. That's methanol. So I've got to go through moles. And so what I like to do is often build myself a little table, right? I'm looking for the volume of H2, right? So let's make that red, right? This is where I'm trying to get to. And I'm given that I have 35.7 grams of methanol. And so, without even knowing anything, I'm doing stoichiometry. They gave me the amount of one thing, they wanted the amount of something else. I've got to go through moles, right? So I've got to get the moles of methanol. I'm going to get the mass of methanol into moles. And how do I go from mass to moles? Well, I would use the molar mass. And then how do I go from moles of methanol to moles of H2? Well, I'm going to use the balanced stoichiometric coefficients. So I'm going to use that 2 moles of H2 will react to give me 1 mole of methanol. And then they want, once I have the moles of H2, they want the volume of the gas, and so I'm going to use PV equals nRT. Now, we could do this as, sort of one long problem, but sort of, using PV equals nRT like a unit conversion, I don't care to do it that way. And so what I'm going to do is I'm just going to do this in 3 steps. Now, of course, as we've done stoichiometry in the past, going from grams of methanol to moles of H2, we could do in 1 step. But I find it easier in these, when I'm thinking about them, to just do it as 1, 2, 3 separate steps. So to do this first step, I need the molar mass of methanol. So the molar mass of CH3OH is 1 carbon, 4 hydrogens, and an oxygen. So when I add that up, I get 32.05 grams per mole. So the first leg of my journey, and that gives me all right, so right now I'm here. All right, so now I'm going to use the stoichiometric coefficients to go from moles of methanol to moles of H2. Right, and then the 1 mole of methanol should go on the bottom. Two moles of H2 on the top. Right, so now I'm there. And so to go from moles of hydrogen gas to the volume of hydrogen gas, I'm going to use PV equals nRT. And so let's rearrange that for volume. So I need to divide both sides by P. So V is nRT over P. I have the moles. Let's go up and see what else we have. I have the temperature. That's, oops, sorry. I have the temperature. That's in the right units. And I have the pressure, but I need that to be in atmospheres. Right, so I need to convert millimeters of mercury to atmospheres. Now, this is a conversion factor I'd give you, but you may know that 1 ATM is 760 millimeters of mercury. And so I'll take my 738 millimeters of mercury and my pressure in atmospheres is 0.971. So now I think I have everything I need. So my volume is going to be my 2.22 moles. And I'll do the units off to the side. R, the temperature was 355. Divided by the pressure. And so then I have, for units, moles, liters times atmosphere over mole times Kelvin. Kelvin in the top, and then in the bottom, my atmospheres. So moles, moles, atmospheres, atmospheres, Kelvin, Kelvin. I'll be left with liters, which is good. And so when I do that math, I get 66.6 liters as my final answer.